Okay, so today I'm going to go ahead and talk about how to find the center of mass for a two-dimensional object. So we will assume the object has a uniform mass, which is the only way we'll be able to do problems like this when I go through this process. Okay, so here are the steps that I wrote to the side. So first thing, let's do a coordinate system for 2 dimensions. So I'm going to say this is the y and this is the x. So we'll say like it starts at 0, 0, 0, goes to 1 right there, goes to 2 right there. Cool. Now let's go ahead. Let's take a guess where the center of mass is. So I'm going to think to myself like, there's more mass down here at the bottom and slightly more mass to the right. So I'm going to guess that the center of mass is somewhere around there. And let's go ahead and see if I can write the word guess. Let's go ahead and see if how close my guess is to what it actually is. Cool. So now let's pick a mass for the whole object. So we're on to step number 3. Pick a mass for the whole object and divide into shapes. So this has a total length of 3 meters right there. What I'm going to do is I'm just going to pick a multiple of 3 for the mass of the object, just to make my life easier. I'm going to say the whole object, let's say it has just like a mass of 6 kilograms. So if this whole object has a mass of 6 kilograms, then this part right here of 2m is 2/3 of the total. So this is going to have a mass of 4 kilograms. And this piece right here is 1/3 of the total mass, so it's going to have a mass of 2 kilograms. Cool. And that's just an example. You could choose like 3 kilograms for the mass, 9, whatever. Heck, you could choose 5, but it just gets a little trickier, the numbers. I like nice, even numbers. Cool. Now I'm going to choose the center of mass of each shape. So we know that if there's an object of uniform mass, it essentially acts and moves as if all the mass was at the center of mass of that part. So right here for that little portion right here, the coordinate system of that would be x would be what? 0.5, and then y would be 0. So the center of mass of the bottom 1 meter piece is 0.50. Now for the other piece, let's see, it's at 0x and it's 1y. So that's the center of mass of that. Cool. Now I just calculate the center of mass in the x and y. So the x center of mass is going to be m1 x1 plus m2 x2 divided by m1 plus m2. So we're essentially just looking at 2 objects right here. So m1 is going to be, I'm going to say m1 is the bottom one. So that is 2 kilograms times x1 is 0.5 plus m2 is 4 kilograms times x2 is 0 over the total mass, which we said was 6. So this turns out to be 2 times 0.5 is 1. So this is just 1/6. Cool. So that's 1/6 meters for the x center of mass. Now let's look at the y center of mass. So that's going to be m1 y1 plus m2 y2 over the total mass. Let's see, so m1 is going to be, again, that was the bottom one, so 2 times 0 plus 4 times 1 over the total mass, which is 6. So this is just going to be 4/6 meters. Cool. Which is the same, I guess I could simplify that to 2/3 meters. Cool. So if I write that as a coordinate pair, it'll be 1/6, comma, 2/3 would be the center of mass of this system. So let's see how close my guess was. So 0.5 was the center of mass, so it was to the left of that. It probably should have been a little farther up, but hey, not too far off. I kind of like my guess. So cool. Thanks for watching.